All right, so let's take a look at number 96. So here, this one doesn't have more than one variable, as it just has one variable, but it's out of order, right? So remember that we want to write these in standard form when we're factoring, because it just is how we're used to seeing them, and how our rules work. And so what I'm going to do is I'm going to put this in descending order. So it's going to be 2a squared. So this is going to come first because it has the highest exponent. Then the 3a next, positive 3a. And then this is going to come last because it doesn't have a variable, right? So that means it's variable to the 0 power, right? Then visible because that equals 1, right? Okay. All right. And so this one's a little different because we talked about these trinomials where a equals 1, but here the number in front of the variable squared is actually a 2. So the leading coefficient is 2. So it's a little different. But because we have the 1 here, it actually makes it the pretty much the same rules apply. Okay. So I'm going to set this up like this. And since this is a 1, the only way we can multiply to get 1 is if we multiply 1 times 1, right? If we're talking about what are the factor pairs of 1, it's just 1 in itself, right? 1 times 1. And so we know that's going to be the case. And then we're going to, since we have a squared, we're going to put an a here and an a here. But notice that I'm leaving a little space in front of the a's for coefficients, right? Because it's not just a squared, it's 2a squared. So I need something here and something here that I can multiply together to get 2. All right, and you might already know what those are going to be. So, but let's go through the process. So we're looking for numbers we can multiply to get 2, right? All numbers we can multiply to get 2 that we can add to get 3. Okay, so we kind of use the same process, but we use this number. Since this is a 1, we're using this number to multiply, to find numbers we can multiply, and then we're going to still use this sign that we can add to get the middle number still. Okay, if this was a minus, we would subtract. So numbers we can multiply to get 2 that we can add to get 3, that's 2 and 1. So I'm going to put a 2 here and a 1 here. The 1 is optional because we have an a there, so I'll just take the 1 out. It'll be invisible. Okay, now we look at this sign here. This is the sign of the bigger number, but here it's a little different because remember, we're going to be doing this. And so 2a is the bigger number, right? Bigger than 1a, but it's going to be multiplied by whatever this number is and whatever that sign is, right? So we want that sign to be, that's going to be basically the sign of the bigger number when you FOIL. And so we want that to be positive. And then in this case, since this is positive, that means the signs are the same. And so this will be positive as well, okay? Because the signs are the same. All right, so that one's a little tricky, and there's nothing else we can do here. Those are not difference of 2 squares. There's nothing more we can do with that, so that's our answer. All right, so let's take a look at number 88. So 88, here we have, first of all, a negative leading coefficient. Second of all, we have a cube, right? Everything's in order, so that's good. But they also share an a, right? And so remember, the first thing you want to do is check for a GCF. And so first of all, if the leading coefficient's negative, we want to make sure that we factor out a negative with our GCF. And then they all share a, so we take an a out, and we're going to take the one with the smallest exponent, right, which is this invisible 1 here. So we're taking a to the first power. Okay? And I don't see anything else in common, so now we're going to put our leftovers back inside. So remember, what we do is divide. So we're in our head or on paper, we're saying, okay, what's negative a cubed divided by negative a? And that would be positive a squared, right? Then we're doing negative 2a squared divided by negative a. And that's going to be positive 2a. Okay, and finally, what's negative a divided by negative a? And that's going to be positive 1. Okay, so now we have negative a, and then we have, here we have a 1 there, so now we can do our normal factoring. So we put an a here, a here. We're looking for numbers we can multiply to get 1, that we can add to get 2, right? So that's 1 and 1. The sign of our bigger number is positive, so we're going to put a positive. Since they're both 1, it actually doesn't matter which one we put in, right? Because these are the same. We don't have really a bigger number now. But since this is also positive, that means their signs are going to be the same. So this is going to be positive. Okay. So that's our final answer. But if you notice, these are actually the same, right? So we could actually rewrite this as a plus 1 quantity squared. And we could have done this a little differently, right? At this point, we could have recognized that, hey, this is a perfect square, this is a perfect square. And if we take the square roots, we get 1 and a. And if we multiply those together and double it, we get 2a. So that was actually a perfect square trinomial. So we could have gone straight from here to here if we wanted to, using that method. Okay, so it's kind of up to you. You can use either method, and this is okay to write as a final answer too. So you don't necessarily have to write this, but either way is correct. All right, and you can choose now that you have two different ways to do it. You can choose which way makes more sense to you.